degrees Fahrenheit. The water is heated for 30 minutes, beginning at time t equals 0 to values of WT at selected times t for the first 20 minutes are given in the table above. Use the data in the table to estimate W prime of 12. Show the computations that lead to your answer using correct units. Interpret the meaning of your answer in the context of this problem.
Okay, when they say it's twice differentiable, it just means you can find the derivative, meaning it is a continuous function. So let's figure out what's happening here. W prime is a derivative of W, is that right? Okay, and if I were to look at flashcard number 5A, it says to find the prime, you basically use a slope formula. So let's see where the 12 is going to go. So if I look at the value on my t equals 12, does that exist? Not really, but we know it's going to exist somewhere in between. So that means I'm going to find the average value between these two. And by that, I'm talking about the slope formula. So let's write out W prime of 12. And let's put on here flashcard number 5A. And I think 5B is going to be helpful too. Is equal to W of 15 minus W of, ooh, I made a mistake on that one. Is the 12 on there? Shouldn't it go right here? Oh. Anyone notice that? Yeah, you guys were like, what is she doing? All right. So then we have W of 15 minus W of 9 all over 15 minus 9. And when we do plug things in place of W of 15, what's our Y value? 60 what? 7.9. What about W of 9? 61.8. And 15 minus 9 is 6. Let's type that in. We have 67.9 minus 61.8. Divide that by 6. And that's going to give us some value. And the way you're allowed to round, you could say 1.016 or 1.017. Because I'm a math teacher, I should use the rounding rule, but you don't have to. And when they say interpret, that means they want it in a sentence. So we're looking at the water temperature. The water temperature, I'm going to write H2O because why not? It's increasing at the rate of, at the rate of about 1.017. And then we're looking at it from Fahrenheit per minute. So I'm going to write Fahrenheit per minute. Do we put the degrees after or before? Does it go after? Okay. And then you have to mention exactly at where. We computed at W prime of 12 at t equals 12 minutes. You have to repeat yourself. Always, always. So let's score ourselves on this one. Knowing to use our mean value or the average, or also the slope, that's going to give you 1 point. And then the whole sentence stem with all the keywords, 1 point. Let's also write something on the top. Let's write raw out of 54 and potential out of 54. And then for number 1, let's also write how many out of 9 for raw, how many out of 9 for potential when we're done with all the A, B, C, and I believe there is a D. Okay, y'all good with that? So this is very doable, okay? Moving on to the next one. Andrew, let's read part B.
Use the data in the table to evaluate integral 20, 0, WT, dt. Using correct units, interpret the meaning of, whatever, in the context of this problem.
You can always say the function. So we have our flashcard number 6B is going to be helpful. So we're going to find out how we can match this to flashcard number 6B. So this right here. So in place of W prime of t, it's going to be F of t. In place of F of B, it's going to be without the prime. Y'all see the pattern? Okay, so let's write that down. We have the integral from 0 to 20 of W prime of t dt is equal to W of 20 minus W of 0. And we have those values actually. Abby, what's on W of 20? from the table?
71.
71. And Ian, what's on W of 0? 55. And if I do 71 minus 55, and again, if you're allowed to use a calculator on number 1 and 2 on the FRQ, might as well. We got 16. And it says, explain the meaning of it. So, let's write on here, the water temperature. Temperature. Did it go up or down if I have positive 16? Went up. 16 degrees Fahrenheit from T is equal to 0 to T is equal to 20 minutes. And again, you have to mention the 0 to 20 because that's where we evaluate it. So having our flashcard number 6B and plugging things in, 1 point. Explaining in Word with all the key words, 1 point. Again, that is doable, okay?
Sorry.
Could you hear me though?
Yeah.
Okay. All right, Ian, let's read part C.
For 0 is less than or equal to T is less than or equal to 20, the average temperature of the water in the tub is 1 over 20 integral from 0 to 20
Wait, what's this one?
W of T dt. Use the left Riemann sum with 4 subintervals indicated by the data in the table to approximate 1 over 20 integral from 0 to 20 W of T dt. What does this approximation overestimate or underestimate the average temperature of the water over these 20 minutes? Explain your reasoning.
All right, this value right here, that's the integral part. That's the Riemann sum. The 1 over 20, if y'all remember, is the average value. And it is the average value because it's a temperature within the 20 minutes. So let's kind of recall our left Riemann sum. So let's start off by writing out 1 over 20. And then we're going to apply the Riemann sum. So let's see if y'all remember. And how many subintervals on this one? 4. So I'm going to use my different color. Let's make 1, 2, 3, 4 loops. Okay, so on this one, is 55 on my left or 57.1 on my left? 55. What's the jump between the 0 to 4? 4. So here I'm going to write on here 55 times 4 plus, on my second set, between 57.1 and 61.8, what's on my left? 57.1? That's a 7. And then jump between 4 to 9 is 5. And then what's the next number we're going to write out just by looking at the pattern? 60 what? 0.8. And then our jump between 9 to 15 is 6. And my last one is 67.9. And the jump between 15 and 20 is 5. You do not use 71 because 71 is on the right side. Let's type this in exactly as you see. Type it in. Andrew, close up. We're not done yet. And Laura's, let me know when you have your decimal value.
I got 60.79.
Good job. And then we have to actually explain this. Before I explain this, let's think about key concept on number 1. It says the temperature in the tub is strictly increasing. Go ahead and box that. When it is strictly increasing, that means temperature is doing this. It is concave up. Draw me a concave up. Okay? So then here's my left, here's my right. It says use left Riemann sum, make your rectangle. And then keep your eyes on the board again. Here's my left, here's my right. Make your left rectangle. Here's my left, here's my right. Make your left rectangle. And when I shade in the rectangle using the left Riemann sum and using the area under the curve, is it filling all of it or most of it? Most of it. Now, by most, are we going over or under the approximation? It is under. So I'm going to use my sentence stem right here. I'm going to say the approximation is under because so on. So this oh, we're not allowed to use this. Like it, this, and that, we're not allowed to use. So let's go ahead and put on here, the left Riemann sum is an under approximation. Because W of t is strictly going what? Increasing or decreasing? Increasing. Drawing alone does not give you any points. It's going to help you understand it. Now there's 3 points embedded on this one. Knowing to use the left Riemann sum with the average value that was given to you is 1 point. And then correctly putting it into the calculator, that should be an easy freebie, 1 point. And explaining, and we can't use the pronouns. You can't say this, that, it, we can't. Okay, so if at all possible, go back to the question and be like, what did I find? I found the left Riemann sum. Okay? All right, let's go on to our last one. Abby, let's read part D, please.
For 20 to t is 25, the function w that models the water temperature has first derivative given by w of t equals 0.4 square root t cosine 0.06 t. Based on the model, what is the temperature of the water at time t equals 25?
Okay, something that I have to mention, the temperature. The temperature alone is not the rate. So if I tell you I give you the rate, W prime, and I integrate it, would you all agree that those two cancel each other out and it does give me a temperature? Yeah, it is the actual function. So looking at flashcard number 6B, we're gonna use the fundamental theorem of calculus one more time. So we have to go from 20 to 25 of this value. So we have the integral from 20 to 25. And we will be finding this value in the end. So we have W prime of t dt is equal to W of 25 minus W of 20. And let's plug in some things that we know. Not plug in, let's rearrange. I am looking for W of 25, so I want to put this by itself. So if I make that by itself, applying algebra 1, I have to move this guy over, right? So that's going to give me W of 20 plus the integral, and I won't read the whole thing. And then from here, it's going to be pretty simple. On our table, Andrew, what does W of 20 say on our table?
71.
71. And then we're going to use our calculator for the next one because we have the function of W prime. So for that piece, let's use math number 9. And we're going to literally type it in exactly as you see. So here we go. You got your calc? Make sure it's on. Start with 71. And then put in the plus sign. And now go to math 9. It'll bring the integral from 20 to 25. And then we have to put in the whole function in that is given to us already. 0.4 square root of x. And then I have cosine of 0.06x. Close it. And notice it's got double parentheses because the calculator wraps it all up at all times. So let's make sure we have the exact same thing. When I press enter, because it's strictly increasing, should it be less than 71 or greater than 71?
Great.
It should be greater. That will be a good self-check. So when I press enter, is my number greater? Yep. So we have 73.043. And as a good practice, let's also write that as W of 25. And here's our point system. All this right here is 1 point. And this one did not say explain or any of that. So your final answer with the units, degrees Fahrenheit, is good enough. And by the way, apparently the degree is supposed to be at the beginning. I made that mistake on part A. So let's make sure that is 9 points. So we have 3, 4, 5, 6, 7, 8, 9. So on the front, I want you to write, what is your raw score without my help? Let's say I did part D and you knew how to do it. Give yourself credit on the raw score, okay? And the potential as in I had some aha moments with a little guidance.